let's do a little bit more logarithms, of course, with the second video. So let's tackle, I think you guys can do 32 to 35 on your own. It's just a small review. Now let's do something in this section, 36 to 41, where the instruction says, evaluate each expression, which is in log form. Do not use the log function in the calculator, even though you technically, if you really want to, you could. But I'm just going to show you how you could evaluate this without the log function in the calculator. I'm just going to put the steps over here, and I'll just do number 38. Okay, so the first step is you're going to set this expression equal to x. Okay, so set this whole expression equal to x, and then you're going to change it back to exponential form. All right, so let's just follow those steps right now. So let's set it equal to x. So this is what I mean. Bam. All right, number 1 is done already. And then now we're going to change it to exponential form by checking out our base. So our base is 5. Okay. What is our exponent? It is unknown, so this is going to be x. Okay. And then is equal to our argument 1 over 25. Now we've done this work before in a couple of the previous, I think it was like in one of your almost every single way to solve for x, and I kind of forgot which part. But now we just want to change it and match it up to the same base. Then that way we can solve for the variable which is at the exponent. So let's go change this base. 1 over 25 is going to be 5 to the negative 2. Okay, so this is going to be 5 to the x is equal to 5 to the negative 2. I've changed 1 over 25 into that. Now we can set the exponents equal to each other because we have the same base, and we actually solve for it. X is equal to negative 2. Okay. There might be a few more steps that you have to do in some of the harder problems like this, but this is really basically how to evaluate this expression. Just follow these 2 steps over here and then solve for x by changing the base if it's needed. Sometimes when we go past 41, and let's do number 42, sometimes it might be a little bit harder to change the base. Let's see if we, let's try to actually do these steps over here on numbers 42, and you'll get to see why it might be a little bit difficult to do this by hand. Okay, so now let's change it into exponential form. 8 to the x is equal to 39. I don't know how to change 39 into a base of 8. So it's going to be a little bit difficult. This is where your calculator comes in. So you can definitely use calculator this time around. You know, IDK, I don't know. So if you have your TI-84 right now, I think sometimes Desmos.com will also have a scientific calculator with that. There's a couple apps that you can also download too for your calculator. And I think that's on your resource and in my syllabus as well. And you can find those links. Anyway, I think we can hit math. And then let's go to number. You know what? I kind of forgot where it was. Where is it? Where's the log? Oh my gosh. It's on math. So, you know, when you haven't done logs in so long, you know, like for 2 years, then it's there. Okay, so it's on math. Let's try that again. Math. And it's on A. Okay, log base. Okay. So what that is if you do have the TI-84 plus CE, then now you just kind of input. Here's the 8. Plug in the 39, and it'll do it for you. Okay. We're going to do 1.762. 1.762. Tens, hundreds, thousands, this is fine. Okay. I do want to tell you guys some of the AP rules right now. Some of the AP rules in terms of decimals is where do you cut off for decimals if it's repeating like this, or if it goes on forever, or if there is a stop, like how many decimal places do you need? You go to 3 decimal places, and you could either round or not. Okay, so it's up to you. I rounded on this one, so 0.762. Actually, the past 3 years, I haven't been rounding. So you could either do 1.761 or 1.762. AP will accept either one. They will not accept 1.763 or 1.760. So it's either one of those. And actually, I'm gonna do 1.761 because I've just been doing it this way for the past 3-4 years. It's up to you. I'll also accept 1.762. That's fine. Okay. All right. .48 logarithms are equal to exponents. Let's do 52. So to do stuff like 49, I'll show you guys how to do that by doing 52. So to solve for x or to solve for that variable, let's just get, let's do it. Plus 7, well, let's just minus 7 on both sides. Then this is going to be 2 to the negative 6n. I want to capitalize my n just for right now. 84. Okay. It's going to be a little bit hard to change 84 into a base of 2 because this is not even a multiple of 2. I mean, it's not a, 2 to the 3rd power, 2 to the 4th power, 2 to the 5th power. That list that you guys made, 2 to the 6th power, I mean, it's already passed already. So it's not within that realm of the power of 2s. So what we're going to have to do is we're going to change this into log form. Hence, I'm going to put log over here. Our base is a 2. Our argument is 84. And we're going to equal that to our exponent, which is negative 6n. Okay? So logarithms are equal to exponents. We're almost done. Then we're going to divide just both sides by negative 6, and you are done for the day, actually. N is equal to, and you can put the negative on the side, log of 84 base 2, 6, and then you can make it negative like this, okay? And we're going to box it just like that, just because the instruction says solve each equation exactly, so we're not going to put it in the calculator. This is fine. Okay, so you can just leave that. Okay. So if you have exponential form, get rid of all those outer things like the plus 7. Sometimes, maybe there's that times 3, so divide both sides by negative 3 first. And then once you have your base, log, and your argument, change that into log form, solve for your variable. Okay, I think maybe I can do a couple more. Oh, yeah, 57, and then, oh, no, there's more to do. Okay, there's more to do. 57. Solve each equation approximately. Really, this time around, once you're in this step over here, where you're just going to use the calculator, that's what's going to happen. And let's just do 59. There's no outer things over here in 59. Like I don't see like a plus 7 or a times 3. We can change this into log form already. Log. We got our base 9 over here. Our argument is 33. And then that equals to our exponent, negative 4.3v. We're almost done. Because from here, we're going to divide both sides by negative 4.3. Negative 4.3. V is equal to, so now, use your calculator. Where's our log button again? I think it's on option 9. I'm just going to go. That's what happens when you don't use it for such a long time. Base 9, argument 33, okay, and then divide it by negative 4.3, okay, and then let's just use this, negative 0.370, the other number is 0, so we'll cut it off to, I know it says 10 thousandths, let's just do AP style and just do thousandths instead. 3 decimals, AP style. So you could either round or not. Not rounding is called truncating. I really just want to check if that was a correct answer. It's just 57. Yeah, I mean, like if you wanted to add that 1, but we're not going to add that 1 over there. Okay. Okay, 61, and then I can tell you 61, 66, then I can probably tell you guys what numbers to do if you want to do some more work before you move on to the next video, or it's up to you guys. Okay, it is in log form, and you want to solve for whatever that argument is inside. And so right now, well, first, you want to get rid of anything that's outside of the logs, and I think everything outside is okay. Here, if it's in log form, you're going to change it back into exponential form. Okay? What is your base? Your base is 3. What is your exponent? It is this 3 over here. And then your argument is x minus 6. You're almost done. 3 to the third power is 27. Add 6 on both sides, x equals 33. I'm going to ask you guys to have the habit now of checking your work. The reason why I am saying this is because, okay, I'm just going to write it over here. If you have log of something over here, this whole thing, after you do all your additions and subtractions and everything, you can't have a 0 or negative inside. So let's just check just in case, because there are a couple answers that we might have to reject because it makes it into a negative or 0. So let's just do some checking here. Log base 3 minus 6 is equal to 3. And then let's just put the question mark. We had said it is 3. Okay. Um, 33 minus 6. I don't know why I can't even do that in my head. 27. Okay. I think this will be okay already. This is a positive number, which is already good. It's not a 0 or negative. And then if we really want to go further, if you want to change it into exponential form, 3 to the third power is 27. Okay, so we got to check, and that is good. Okay, let's do something like number 66. And I can tell you guys what problems to do afterwards. Let's get rid of so 2 minus log of 5x plus 8 is equal to 4. I would try to get rid of this 2 first. It's positive 2, so I'm going to subtract 2 on both sides. Negative log 5x plus 8 is equal to 2. Okay, if you do, let's go get rid of that negative by dividing both sides by negative 1. Okay. If you do not see a number, like that base over here, it is the assumption that it is a base of 10. Okay. So if you do not see that number, you need to grab that number. The assumption is the base of 10. Otherwise, they'll give you the number, like, 9 or 8. So if you don't see the number, the assumption is 10. Now, there's nothing around the logs. We can change this back into exponential form. So your base is the 10. Your exponent is the negative 2. And then our argument is going to be that 5x plus 8. Hey. All right. I'm just going to have to change this. 10 to the negative 2 is going to be 1 over 100. Okay. We put the 10 into the denominator, and then 10 squared is going to be 100. I'm just going to have to just use my calculator, really, minus 8, minus 8. I'm not going to do this by hand. So where is... Oh, we do have that fraction option. Let me just see if I remember correctly. On the number, so I'll hit math again. So math, and then on the number, I'm going to go up. You have a couple fraction things that you have options for. I usually use D, numerator over denominator. Then that way in the TI-84 plus CE, it makes it into a fraction. 1 over 100 minus 8. So negative 799 over 100. Negative 799 over 100 is equal to 5x. And then we're going to divide both sides by 5. So you really do not have to worry about, if you have a calculator like this, don't even worry about fractions at all. It will just do it for you. Divide by 5. So negative 799 over 500. Negative 799 over 500. Okay. I do just want to check to make sure that we just do not have a negative in there. So what I'm going to do is that I'm just going to just use this portion over here, okay, and just make sure negative 799 over 500 that whatever's inside of the log is not a negative, because if this makes it a negative or a 0, we can't use this answer. So let's just check. Okay, 5 times, and then I'm just going to grab the answer. So to grab that answer, you just hit the up button over here, plus 8, and then hopefully, okay, good, it's positive. Okay, good. Okay, this is positive. That's fine. If it had been a 0 or a negative, we could not accept that answer. So we can't accept this answer. This is okay. All right. Okay, so I think I've been teaching already for 15 minutes. You guys can move on to the next video, or 74 will be the highest one. So 74. So 32 to 74. So do numbers 32 to 74. If you don't want to move on to the next video and you want to do all your problems first. Otherwise, I'll see you guys on the next video.